Hello there. It's time for an update video on my Hydro Thunder arcade machines. These things are still just incredible to have, and I have to pinch myself every now and then that they're right there. Now, if you haven't seen my previous video on these are my Hydro Thunder arcade machines, which I had to completely tear apart to get them into my upstairs office. But that afforded me the opportunity to get very comfortable with how they're put together and learn more about how they work. And I've taken that knowledge even further over the last couple of months because I have now finished 3 different projects related to these machines. They have been cloned, both virtually and physically. I have found a fundamental flaw with them that has been now repaired with new replacement parts. Oh yeah, 2 fundamental flaws. And I have hacked the machines, and I now have the world record high scores on this one. So today we're going to go over all of the work that I've been doing over the last few months, and I'm going to teach you how you can maintain the computers that run the games with standard consumer grade hardware. I'm going to release the design files that I created to address the faults that I found, and we're going to go over the really interesting software that I wrote with some amazing help that allows us to hack aspects of this game. Now, the first thing I want to go over is cloning the computer in this machine. As we saw in the previous videos about this, Hydro Thunder isn't just an arcade game, it's actually a computer game, although not that version. The copy of Hydro Thunder that runs on this machine is not dependent on a standard MS-DOS operating system or Windows environment. It instead uses a custom loader to launch the executable almost directly on the hardware, and that is how the game runs. But the game has a Voodoo 2 with a custom security chip in it, which means that without the dedicated hardware that this computer came with, it's not possible to run it on any other system, despite being a standard Intel motherboard with a Pentium 2 and other off-the-shelf hardware. Or is it? This is my tiny Pentium computer running Hydro Thunder. But it's actually the regular PC version, which it meets the absolute minimum recommended specs for, and really isn't very capable of running it. It stutters and lags a lot. But what we need to continue is the graphics card from this computer. So, regrettably, I need to get it open so I can extract that. That graphics card is a 12 megabyte Voodoo 2, which is the only graphics card I own capable of running the actual arcade version of Hydro Thunder. The graphics cards inside of the arcade machines themselves are a Quantum 3D Voodoo 2 that has 10 megabytes of video memory, which is a configuration not released to consumers. Retail cards were either 8 or 12 megabytes. The 10 megabyte card is unique. So you have to have a 12 megabyte Voodoo 2 in order to do this. Now I have my Voodoo 2. Great. What am I gonna put it in if the tiny Pentium isn't capable of running the game? Well, I put together this. This is a computer that has a slot 1 Celeron 333 megahertz, just like the arcade machine. Though you don't actually have to match the CPU requirements quite that tightly. You can use pretty much whatever x86 CPU you want as long as it's faster than what the arcade machine came with. I just wanted to get as close as I possibly could to the hardware in this test. Now, I also have the 64 megabytes of RAM, which was what the arcade machines came with, but everything else from there has a little bit of wiggle room, which is one of the reasons why I bought this, a Yamaha YMF 724 sound card. I mentioned that I bought this in the Do Multi-Monitor video specifically for this build because this is a similar Yamaha XG chipset sound card as to what came on the original motherboards of the Hydro Thunder arcade machines. So what I'm going to do here is pop the Voodoo 2 in one of the PCI slots and the Yamaha XG sound card in another one. And that's pretty much it. Next up, we need the software, and I put that on an SD card, and I just have an SD card to IDE adapter right there to use with this system. That is a hard disk image of my actual arcade machine drives back there, and with that in there, it should be able to work. I've also gone ahead and added a plain 2D VGA card and connected the Voodoo 2 pass-through cable on this, so hopefully we can see post and then boot into the game. With that, I'm going to flip the power supply on and boot the computer. And that looks pretty normal, but oh, something's not right there. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. If I grab the operations manual here and look in the back, we can see that 6 short beeps means peripheral problem. Now, we could take this computer over to the arcade machine and try and plug it into that, but I know we're gonna run into another issue, and right now seems like a good a time as any to introduce a solution to both of these problems. Now, to get that hardware clone system working, I'm going to rely on the work of someone else who has put a lot of effort into making this possible. Linkin Park 9812 on the Arcade Museum forum. The work they have been doing here is absolutely phenomenal. They've gone through the main Hydro Thunder executable and found a bunch of hacks that can be done to change how the game works. So the first thing I want to show you here is a diff of the original Hydro Thunder and the modified one that they have started working on, and they also detail how you can modify your own executable. Now, the first thing I want you to notice here is on the original game, we have all this random hex data, but on the modified one, we have all of these 90s. 90 in hex is the no op code on the x86 platform, which is the no operation. It means the CPU does nothing when it reaches this instruction cycle. This has been done to bypass the check for the security chip on the Quantum 3D Voodoo 2 card. This means that any Voodoo 2 that is capable of running the game now can, because without that check, there is no restriction on what hardware it can run, except for the Diego board, which is the main check for how all of the data gets into and out of the game. There is a way of defeating that as well, though, which we'll go ahead and do, but without that, you can't play the game because you don't have any controls. All right, now that I have a modified copy of the Hydro Thunder game, I should be able to pop this in here and fire this back up and have it work this time. And that is confirmation right there. It's not much, but that text is rendered by the Voodoo card only, which means in a moment, there we go. That is the game running on unofficial hardware. How cool is that? So it is entirely possible to build a complete clone computer to replace your original Hydro Thunder arcade machine with if the computer in it should ever have problems. And I just have to say, awesome job to Linkin Park on the Arcade Museum forums. This is a very great step towards maintaining this hardware. Now, as a vintage computer enthusiast, reaching this point is great, but I have access to hardware and questions, so I was curious if I could get this to run on other Voodoo hardware of this era. So I have a Banshee, a Voodoo 1, and a Voodoo Rush. And I've tried all of these in this computer as well with this, and unfortunately, none of them work. The Banshee is the only one that has enough memory for this, and it's not even close to compatible, probably because it's an AGP card. The other two don't work because they're both Voodoo 1s really, and this uses the Glide API 2, so yeah, it's really only going to work with a 12 megabyte Voodoo 2. Now, I haven't shown the sound card working in this yet because I actually want to take this over to the arcade machine and run it from it. But there is one more piece of hardware that we need to put in here, and unfortunately, I don't have a clone solution for that, but it would be pretty easy and you could actually figure it out from the service manuals. And that is this. Mine is different from every other Hydro Thunders because I have like weird early production units or something. On most of them, this is just a little PCB. But all this does is take in two Molex power connectors from the power supply and connect this to the reset header on the motherboard and have them exposed through a PCI bracket on the computer, and then a wiring harness from the arcade machine plugs into this. This would be very easy to clone. I want to do it, I just haven't got around to doing it yet, but for now, I'm gonna go ahead and put the one from the actual arcade machine in here just so that we can demonstrate this. Okay, I've got the computer over here and connected to the real cabinet, which, man, makes that case look a lot smaller than it really is. But I've gone ahead and modified the copy of the game operating system on the SD card so it does not skip the Diego board initialization, so it should use the controls now. And with that and everything connected, we should be ready to go. So I'm going to turn on the cabinet first. And the only thing that's going to do is light up the marquee and put power to the CRT. The control panel and everything else, speakers, rumble, motor, are all powered from the ATX power supply in the computer. So yeah, let's get that on. As that fires up, we can now see the lights on the dashboard are lighting. That will do that over there. And this is going to take a little bit of time to get through the post, which doesn't show on here because I've removed the 2D card because this doesn't do 640 by 480. So we're going to have to wait a moment, but it should show up over here. And that is the game running on that computer. Let me adjust the monitor so it's not going to flicker on you. All right, now that this is running, you probably can't hear sound here. I've added a stereo inline volume wheel that allows me to make the volume setting hardware rather than software, because in situations like this where I've changed out the operating system on it, it resets the volume on the machine every time and then is ridiculously loud. So that lets me set it once in hardware, though it can cause weird stuff. Like right now, it's actually a little tinny. I'm not sure if it's that sound card or this setup, but I suspect it's this setup and that I just need to move the wheel a bit. But we're gonna go ahead and run a race on this just to see. There we go. That's the game running on the computer right over there. And there we go. That was an abysmal time for multiple reasons. At the default settings, the AI is brutally difficult, and the controls are not calibrated, which means that I can't hydro jump or boost start. So don't worry about any of that. But what I really wanted to do was set a high score. So I'm going to input my initials here. Now that I have a high score saved to this, I want to take another look at it back on the other computer. And just in case there's any doubt here, this is this system, power switch, controls that arcade machine. Isn't that cool? Now, as I've demonstrated, with that patched executable, you can run the game on unofficial hardware. But the thing is that it doesn't have to be hardware. It can be software too. Now, unfortunately, I tried my absolute best to get this running myself, and here is PCEM with an emulated computer configured pretty much exactly the same as the actual arcade machine, just without the sound card. And it should be able to boot the game here. There is the startup, and it segfaults PCEM. What I think is happening here is that it is crashing the Voodoo implementation of the code in PCEM, and the exact same thing happens with 86box as well, which makes sense since they share a code base. But it doesn't happen on Windows, and I have Wizard Tim here to thank for the first time, but not the last time, for help with this footage of it running in PCEM. Now, this is significant because, and I actually didn't know this when I bought these machines, this game isn't emulated. It's not supported by MAME, and there aren't any other emulators like Technoparrot that can run it. So PCEM is probably the best hope to get this game running because it is just a computer inside. So going down the road of emulating the computer itself would probably be the best way to go. From here, what really needs to be done is that the Diego board's protocols need to be reverse engineered so that it is known what to feed the game for inputs so you can actually play it. And I guess you would need someone with one of the actual arcade machines and a bunch of electrical engineering equipment to do that, huh? Well, I know what one of my future projects is going to be. Now, as cool as the potential for emulation is, that's not why I wanted to bring you back over to the PC, actually. That has to do with my next part of this project, the hacking of the game. The way Hydro Thunder stores its files on its hard drive is a little unusual. There are 3 different partitions for the machine, and each one of them has a different purpose. The first partition contains the main executable, which is the one that you have to patch when you want to modify the game, as well as a large data blob that I'm guessing contains a bunch of sound and stuff. And the reason I say sound in particular is because the next partition contains a lot of data that is clearly related to the boats and tracks. So if we just start from the top here, Arced, that's probably Arctic Circle. Bands, that's probably the boat Banshee. China, I'm guessing, is the track Far East. And then some other notable ones here, Cutthroat, Midway, the boat, Misbehave, the New York disaster level, Nile Adventure. So it makes sense with those being the 3D objects for the game if this contained the model and texture data. Now there is one more partition on the drives that is always empty, and this has been true for the 2 machines that I have as well as all of the other images that I've seen. And I think this is empty for a particular reason, kind of to reserve space, because there's something missing that we didn't see here. There is the first partition that contains the executable data blob, and I'm guessing some kind of utility, then the other partition that contains all of the model and boat data. But what's missing is the high scores and the configuration data. Now there's 2 significant things to note about this. 1, the game does persist high score and configuration data between power cycles, so it's clearly saving it somewhere. And 2, it does not have an EEPROM, so the only place it could be storing it is on the hard drive. But it's obviously not doing it as a file, which leads to something interesting that I found. Now, I was curious about this. Where does the game store the high score data? So after I dumped my original hard drives, I started trying to poke around and figure this out. So I initially started out by opening the actual full hard drive in a text editor, because you can search for things in here. So if I search for, say, Hydro, I imagine as a text search, it'll find that pretty quick. There we go, Hydro Thunder V0.00. Interesting. So yeah, there's a lot of interesting stuff you can find by just searching text on a full drive image. This is how you do data recovery, by the way, which, fun fact here, the hard drives in these were only ever used for this. So when you scroll to unused portions of the hard drive, it's just zeros. It's kind of weird. Usually when you image an old hard drive, there'll be tons of old deleted data where the references to that data are just gone, and there's tons of garbage in there. But this is still zeroed out from new, which is just kind of fun to see. But the real purpose of looking in a hex editor was to try and find my initials after having set a high score, because the game most likely saved that as ASCII somewhere on the hard drive. So all I had to do was search for my initials as text in the image and let it go. Now when I was doing my initial search, it was getting to this point, near the end of the drive, when I thought it was going to yield nothing. But then it found this, and what we have right here is very clearly high score data, because these are the initials of the former owner and who they knew and played the machine, all laid out here. But the weird thing was that it wasn't a file. This is at the very end of the hard drive, and if this was a file, it would have showed up in that 3rd empty partition, but it doesn't. And no, it's not just a hidden file. It turns out the game writes directly to the raw IDE device at the end of the drive to store the configuration and high score data. Now, one of the really weird things about this, and we can see this on the SD card that I just demonstrated this with, is that it doesn't matter what size the drive is. It's always at the very end of the drive. So if you put a larger drive in, even though the original was only about 3 gigs total, it will always write at the end of the drive. So it's some kind of weird relative positioning based off of the total drive size. So the high scores weren't saved as a file and were written directly to the end of the hard drive. Big whoop, right? Well, not quite so much, because I had a couple of reasons that I wanted to find those. One was that I wanted to preserve the original high scores for these machines, because I thought it would be cool to preserve that as part of the history of them. The previous owners had spent a lot of time and got some pretty good scores on there, and I thought it'd be fun to be able to look back at that as I played it and change those high scores. Since I found all the high scores in the raw data block, I was able to copy that out and save it. But it turned out using that data was a bit trickier, as I found when I tried to do the next thing of modifying the high score data. Now, to demonstrate the challenges with that, I've put this machine back to the normal configuration with one difference. We'll be booting off of a compact flash card. Instead of having the IDE cables connected to the original hard drive, they're routed to this compact flash adapter that allows me to slot the card in from the rear right here and easily access it. I've also connected an ATX power switch to the computer that lets me turn it off without power cycling the CRT and the marquee and other things in here that aren't run off of the ATX power supply voltage. And there is the machine booted from the compact flash card. And I would really like to drive that point home, because there were a lot of comments on the previous videos stating that those hard drives were somehow locked to the motherboards, the only way that you could run the game. Obviously not, since we just built a whole clone computer, but here's the original hardware with a different drive solution. So back at the computer, and we know we can easily boot the machine off of a compact flash card. So I'm gonna plug this in so that we can take a look at some of the data on it and try changing it. Now, we know we don't need to access any of the data on the file system, so we're going to ignore that entirely. And one of the things that I did as I started working on this was figure out exactly which bytes on which drives contained the raw data section that contained the high scores. So on the hard drive, it would be at this byte position because it's a slightly less than 4 gig hard drive, and on this 4 gigabyte compact flash card, it would be at this position. I could then use this with DD on Linux to skip ahead into the drive and then read out only that one part that I wanted, so I wouldn't have to image the entire drive just to modify like 4 bytes to test stuff. So I've already done something like that here, and this is the data from this compact flash card. Now, a moment ago, I let the machine run a little bit, and here we can see the top high score for Arctic Circle was by JBF. So we're gonna go ahead and search in the data section that we have here for JBF, and there it is. And that's the only one in there. So we know this is the high score section for Arctic Circle. Cool. So I can go ahead and change this to something else. So this is 4A. Let's change this to 4 9. So we've now changed it to 9BF as the initials there. We can save this back to the compact flash card now with DD, and then we can put the compact flash card back in the machine and see if that shows up. Okay, we have the game booting off of the compact flash card, and immediately one thing is different. It's asking us to input credits now instead of free play. I'd had this configured to free play, so that's strange, but let's go ahead and wait for the Arctic Circle times to show up and see if we have our 9BF high score. That would be a no. It has reset to SER. Matter of fact, the first position on every single track is SER now because that's the default high score setting. And this gets even odder because if I go into the audit data on the machine by going into the service menu here, under game statistics, we can see it's all zeros. This compact flash card was created by imaging my original hard drive onto this, and all of the on-time hours that were definitely there are now gone. So what this means is it isn't possible to just modify the data to put in whatever you want. It turns out the game actually has a checksum that it uses to calculate if the data is valid. It's not for cheating purposes like this, which we'll get into, but it does mean that you can't easily modify the data, which meant if I did want to try and do something fun like that, it would take a lot more time. Actually, not just time, but also stubbornness and the stupidity not to just give up, because this is the result of me finding this out. This README file is a little out of date, so you'll have to forgive me for that. So what I have here is a Python script that is fully capable of reading and writing from drives the high score data for the game. But maybe in the future, not right now, it'll also be able to change all of the configuration data as well. And I have another massive, absolutely enormous shout out for Wizard Tim, because without their help, that checksum error either would never have happened or would have taken much longer, because I've never worked with anything like that, and they managed to crack it. Let me get that compact flash card connected one more time here, and we'll go over how you can use this. Now, everything for this lives in the HT time program, and we can print the help documentation for this on how to use it, because I've added a fair number of features to this program. For one, we can see the boat and map names by just printing out B for boats and M for maps. These are important because the data for the high scores stores these as individual bytes, not as strings or something. So these had to be mapped to figure out exactly what bytes correspond to what track names. Because one of the cool things we can do with this is now export track times directly to a CSV. Let's start out by using one of my original hard drives for the machines as an example. So if I load in HDDD serial number 33 here, is how I named the file for my own backup purposes, we can read the drive and get some information about it. But that doesn't actually do anything yet. All this is telling me is this is the size of the drive, which tells me that it's not just a raw data block, which I'll get to in a moment, and that this is where the data should reside for the high scores and configurations. But with this tool, we can add a -t and do track times.csv, and we will read that out from there. So now I can vim track times, and There are all of the high scores from my original hard drive in a CSV exported directly from the image. Now you could do this directly from the original drive too if you wanted, but I would definitely recommend, for at least initially, making a backup of your drive as a full image. Now there is some other stuff that you can see in here. Castle Von Dandy, not accessible. There are 2 tracks that are in the Hydro Thunder files, like I mentioned. One of them is Castle Von Dandy, which did make it to the PC and Dreamcast releases, as well as a test track, which isn't really that great. Castle Von Dandy doesn't actually work either, as far as I'm aware. But we do have the high score data exported now. Let's go ahead and modify one of these while we're here, and we'll do Lake Powell since that's the first one that cycles through. And we will name this Hack, because we have hacked it, and we'll change the boat to Blowfish here with a time of 1 second, because why not make it totally impractical and impossible if we're gonna do this? Now here's one of the fun things that I've done with this program. We can now take that track time, and instead of writing it back to our image, we can actually write it with the W command to our compact flash card. So we're gonna do dev SDD, which is where that compact flash card should be, and there we go. But that's not quite the whole story. The game has checksums, and I mentioned that it's not for cheating. The reason that it has checksums is because the arcade machine's kind of dumb. It's a PC, and you just cut power to it to shut it off normally. It doesn't gracefully shut down through some operating system process. What that means is if it's trying to write high scores, when the power gets yanked, it's going to corrupt the data, and then it wouldn't be readable. So that's not good. So the way the game designers worked around that was making there be 2 data blocks. Both of them exist at the end of the hard drive, separated by a bit of space, and the game will write to only one of them at a time in case the power is yanked and that one becomes corrupt. Then the other one is still good, and it just alternates back and forth, and when the game's powered up for the first time, it will check which one of them has the newest data based on the audit information. So what I'm going to do here is I'm going to add -- block, and I'm going to make sure I write to both block 0 and block 1 so that I know both of them should be up to date with the high score information. And there we are, Hack with Blowfish at 1 second. So it's possible to modify the high scores on a Hydro Thunder machine. And I do appreciate that this is a little bit of opening a Pandora's box, because anyone could now lie online saying that they got a high score that they actually didn't by modifying their machine and taking a picture. I would say for speedruns now, you're gonna have to go on actual recordings, but it was only a matter of time before someone figured out how to do this, and I feel like this must be a thing that people have tried to do for other arcade machines in the past, so there's probably already some kind of verification system for things like this. For my purposes, though, I had a different reason that I wanted to do this, and it is related to speedruns and high scores, because now that we can add in high scores, instead of having the previous owner's high scores, which I am starting to beat one by one, what I can do is add all the world record high scores to the machine instead. Now, racing games like Hydro Thunder are far from the only games that people will try to compete to get the best times in, and speedrun.com is usually where people go for something like this. But you'll notice that for the Hydro Thunder arcade game, there aren't even entries for every single track. That's because arcade people have kind of had this thing solved for a lot longer, and Twin Galaxies exists for enthusiasts of this. So this is where the majority of the high scores are recorded at for Hydro Thunder. Now, unfortunately, these aren't presented in a way that makes them really easy to collect into a larger data set, but I went ahead and put all of the best track times for every single track into a CSV file and put the initials of the people who got the times in there. And with that, I can now add all of the world record times for Hydro Thunder to one single machine. And then when I want to try and race against them, I can. Now again, doing this couldn't be much easier. All I'm gonna do is use the world record times CSV file as my times object, and we're gonna write it to my compact flash card. And I'm gonna write it both to block 1 and block 0. And there we go. All I have to do is put this compact flash card back in the machine. And there we are. World record high score times on my actual Hydro Thunder arcade machine. Now, having access to an actual arcade machine It would be fun to try and crack the top 10 leaderboards on at least one of the tracks, and I will probably try and do this at some point, which will mean that I'll want to go through and manually put in all 10 entries for every single track in the game. It's not going to be easy. I wish it could be easier to automate, but I'll just have to bite the bullet at some point. And automating it would be ideal because it will probably change at some points as well as other people try and get new high scores. So this is something that could be optimized more in the future, specifically for trying to get outside high scores. But it's a really cool proof of concept right now. Now, you're just seeing the finished results here, which is somewhat of a frustrating trivialization of this project because I put a lot of time into this and there was a lot of stuff that I had to learn, like how to read and write raw binary data from Python, or how to decode the 32-bit floats that are used to store the track times in seconds in the game. There's also a lot of time spent mapping the data in that raw section of the hard drive. I even switched to using mhex during this project and learned how to use the pattern editor to highlight every single data point with what it actually controls in the machine. A lot of time was spent on this project to create this tool. So I'm really happy that it's finally in a state that's usable and I get to show it off here. But as fun and cool as this project has been, this isn't the one that I feel is the most important that I want to talk about today. One of the things that I had mentioned about these machines in my initial videos was the fragility of the dashboards. One of my units has an aftermarket dashboard, likely because it was damaged to the point where it wouldn't stay on anymore. And the other machine has an original dashboard still that is damaged, and my solution was just to tape it back into place. But I knew there had to be a better way to handle this. And I was able to come up with a solution for that I've been using for this whole video. Right here, I have a new piece that I've created that is able to firmly hold the dashboard in place, despite the fact that the tabs that the screws go into have been completely broken off on mine a long time ago. That piece is this. This is a piece of bent metal that I learned how to design in FreeCAD, but my initial thought wasn't to make this out of metal because it doesn't take a lot of strength to hold, the plastic dashboard to this because none of the other controls actually mount to it. It's only these buttons. So why would I go through the effort of making this out of metal? Well, that's because of this. This is an aftermarket Hydro Thunder dashboard, and this is the one that's on one of my 2 units. If your dashboard has had problems in the past, this was pretty much your only option to try and fix it to make the machine usable. These are, in my opinion, ugly because they're black instead of teal and glossy instead of textured like the originals are. I really don't like these. And they're expensive, so there are no upsides to getting one of these, with the one exception that they're usually intact. Now this one, like the original, is made of vacuum-formed plastic. This starts out as a single sheet that is then heated and stretched over a form to make the shape. But that means that this area right here, which is the mounting hole for this to the rest of the arcade, is very weak because the plastic is stretched here, and this is where it breaks and then no longer mounts securely to the machine. Now, the solution I was just demonstrating is a bracket that goes over this to hold the dashboard in place with a greater surface area of the plastic that should still be intact. And I've had this idea since I first got these Hydro Thunders. So I decided on one of my streams to try and begin designing a 3D printable part for this, because all it has to do is hold the dashboard up. The buttons are the only thing that actually gets interacted with on the plastic. So a 3D printed part would work completely fine. So I set out taking measurements and drawing designs up of what the part should look like to replace this, and trying to figure out what kind of shape it would need to be. I was getting really close with my designs as I was printing them out on a 2D printer and going over and fitting them to the dashboard. But I noticed on the second day, while I was taking over another design revision, something that I had missed that was very surprising. Okay, so this goes on the other side. That's unfortunate. That's the throttle mount plate. It's just tearing straight off. This is that bracket. The throttle for the Hydro Thunder mounts onto here, and it had clearly started tearing the actual metal that holds the whole bracket on. This was really demoralizing to find. I'd already noticed that obviously the brass areas had failed previously and had had an attempted repair made, but clearly this metal is really terrible. I took apart the other unit and also found pretty much the exact same failure. So I started looking on other videos on YouTube and I found Killer Arcade Games, Hydro Thunder, also had a failed bracket. So I realized I was gonna have to fix this thing myself. And while it would have been a lot of fun to get sheet metal stock and a press brake and try and make one of these by myself, I had the realization that it would be far more beneficial to the Hydro Thunder community at large if I learned how to design the CAD for a piece of sheet metal like this, so that a replacement part like this could be made for any Hydro Thunder, much like how I plan to 3D print the bracket to hold on the dashboard. So, after a lot of struggling and learning and figuring things out, I was able to do it. I used FreeCAD to design both the 3D printed part and the sheet metal parts, but the sheet metal stuff was all completely new to me, and I'm glad I approached it with the thought process that I did, because bending sheet metal is a little weird because you have to take into consideration the thickness of the metal, the bend radiuses, and something called the K factor that plays into both of those. And it was an interesting process to go through all of that. But there is a sheet metal workbench add-on for FreeCAD that helps simplify a lot of it. And while I have done 2 revisions of these, one with a bunch of math to try and figure out all the values that I needed, the second one, I leaned more on the plugin and it handled a lot of things for me. The absolute shredded state of the original part made it really difficult to figure out exactly the dimensions of everything because, I mean, it was warped and bent out of shape in pretty much every possible place. So I did my best with calipers to try and figure out exactly what parts I needed, but even that wasn't totally perfect. As I was getting close to done with the throttle mount and becoming confident in my ability to design sheet metal parts, I decided to take another look at my plans for the 3D printed dashboard bracket and figured why not go ahead and make that out of metal as well while I'm going to be ordering sheet metal parts anyway. So I was able to export a DXF of my 3D printed design, make it flat, and then add a single bend to it. And this part actually turned out better than I was initially hoping, so I'm really glad that I did that. After I got both of those designed though, I went ahead and ordered them from Send Cut Send. Now to give you an idea of the cost, I ordered 3 of the throttle mount brackets and 4 of the dashboard brackets. The dashboard brackets it's harder to get a price break on because you have to have them bend the same shape 2 different directions, so they technically count as different parts. But if you're ordering multiple of the throttle mount, you get a little bit of a discount when you order more of them, so that was cool. But I would recommend paying a little bit more to have them put a powder coating finish on it. I had always planned on spray painting these parts, but because it is untreated steel, it relies on the packing oil put on them to prevent rust. And one of my parts just had a little bit of rust form between when they were made and when I got them. And when I got them, I was very happy with the results of what they made. Not quite so happy with the results of what I designed though, because it turned out I'd made 2 mistakes, but I only knew of one at this time. The bolt holes for the tabs that had the studs farther apart, I'd mistakenly used the outside measurement of both bolts as the inside position of the holes, so I had to use a drill press and a file to expand the holes inward a bit, and that was a lot of manual labor on the 2 parts that I had to do it with to make them actually fit, but I was able to do it at least. After that, I degreased all of the parts that I had to remove any remaining packing oil and went ahead and gave them a black spray paint coating. I went with black paint for all of the parts intentionally. Inside, I wanted the bracket that I made to match the 2 different pieces of metal that it was going to mount to. And for the dashboard bracket, I wanted it to disappear into the black paint around the dashboard anyway, though the tabs I put on top are pretty obvious. I still wouldn't recommend trying to paint it in teal because the plastic is going to continue to age in yellow, and matching that over time is going to be nearly impossible. But with all of that, I had my final parts design. Now I did order an extra throttle plate because I wanted one untreated as an example of what the materials look like for this video, because I wasn't able to do any of this work in the office and I have barely any footage of that. So this is what the material looks like when you get it, and I have not done anything to this, and even being untreated, this one hasn't rusted. So maybe the one part was an exception, but still, probably getting it powder coated would work, because my spray paint, even though I did a really good job of waiting like a half an hour between the 4 coats that I put on here, it's starting to chip off. And so powder coating would be a lot stronger. Once I got the parts into the office, I went ahead and started to put the dashboard back together with them. And unfortunately, I found out I made one more mistake on the throttle bracket. It was too tall. Again, it was really hard to tell what the size and shape should be because the original part was so messed up from all the damage. So I ended up just slightly overshooting the height needed on this piece. That was a problem because it turned out the throttle assembly unit has very little clearance between it and the plastic dashboard, and it would poke the plastic of the dashboard away from the proper metal control panel, meaning that my brackets would just snap off the plastic if I tried to put them on too tightly. I've fixed all of these problems in the GitHub repo where I've released the design files for these parts, but I didn't want to reorder them and delay this video and spend another $150 on these parts, so I ended up coming up with a solution where I padded the back side of the dashboard out so that the clamps could still fit on it with the added height of the brackets that I had. After coming up with that solution though, I was very, very happy with how everything went together. For the dashboard brackets, I cut up some felt to put between them and the dashboard so that you would have a softer surface for them to press against that would hopefully also add more friction. But all of the effort was worth it because this is the unit that I currently have all these parts in. I've left the others out of the second one so that I could show you what they looked like, but also because I've spent so much time trying to get this done and put together over the last 2 weeks for just this last section of the projects alone. So I really wanted to get this done, but I am so happy with how this turned out. This dashboard is so solid now, and it's held up in the correct way because of the brackets as well. This piece used to droop down onto the shaft for the steering wheel and was rubbing plastic off, coating it in a green powder. Doesn't even touch anymore. And the throttle bracket is so strong now. Never have to worry about that thing breaking with it being the increased thickness. I did find out there are some plastic parts in there, so you still don't want to rip on it too hard, but you don't have to worry about the metal fatiguing like it has been in all of the Hydro Thunders that I can find documentation on. So it's nice to have those 2 pretty big mechanical failure problems solved. So there we have it. Well, I think that's it for the projects I have done with the Hydro Thunders for now. I'm really happy with the results of these, and I'm very appreciative of the help and what the community members have been getting done out there. The clone PC made possible by Linkin Park on the Arcade Museum forums. The HiScore time hacking tool made possible by the checksum work by Wizard Tim. And for the sheet metal CAD stuff, I have to give a shout out to Shuttlecat and Generic Sweetener, who helped me on Twitch learn how to do this stuff, because that was my first time ever designing that kind of material in CAD, and there was a lot that could have gone wrong that didn't, thanks to the advice that they gave me. So again, I'm appreciative of that. But I think that is gonna wrap it up for here. These machines are still not totally solved. This one has some stretching stuff that's a bit concerning going on, but I might actually have the parts on order to fix that, because as I was working on this video, filming it, I found out that the flybacks for these CRTs have become available again, and I was able to order 2 for both of these machines. That one has a lot of focusing issues that the flyback can't fix, so I'm hoping that between replacing the flybacks and recapping both PCBs, I will be able to get the displays for both of these up and running again. But I'm sure I'm gonna find some other stuff, like I haven't got to the marquees yet, so I should have another round of updates to talk about with these at some point in the future. But that's all I've got for now. If you enjoyed this video, you may want to subscribe to get notified when I have another video talking about the work on the Hydro Thunders. And if you want to see how I'm working on these live, I've been doing a bunch of stuff over on Twitch, so you may want to follow me over there. If you want to help support the channel, you can get a shirt like this one, or find me on Patreon. But for now, that's it, and I will see you next time.